Hey everyone, I'm Becky, your science tutor, and today we're looking at how metals react with acids to form salts. Ever wonders why metals fizz in acid, or how we get useful compounds like copper sulfate and sodium chloride? Well, it all comes down to neutralisation. And in this session we're going to break down how metals react with acids, how to predict the names of the salts that they form, and why these reactions are so important. So let's dive in. Okay, so to get us started, let's have a very quick recap of acids and alkalis. What is it that makes an acid acidic? What is it that makes an alkali alkali? So you're probably really familiar with the pH scale. And in terms of our acids, our pH of acids range from 0 to 6. A neutral solution has a pH of 7, and then from 8 up to 14 we're looking at alkalis. And on this little scale here you can see some examples of those acids and alkalis. So what is it that makes them acidic or alkaline? So the key thing for acids is that they produce H+ ions. And the more H+ they produce, the more acidic they are. So if we think about some examples, such as most common example you're probably going to come across is hydrochloric acid. Now when that is put into solution, that compound dissociates, produces H+ and Cl-. So we're producing those H+. The more H+ we produce, the lower on the pH scale and the more acidic that something is. Now acids tend to have sort of sharp, tangy tastes. I wouldn't go and suggest tasting them, but if you have a look on the scale there, you can see things like vinegar and lemon juice. So anything like limes, oranges that have got citric acid in them. Fizzy pops are quite acidic, and therefore again you've got that sort of tangy taste to them. Okay. In our alkalis then, so the thing that our alkali does is it produces OH- ions. And again, the most common one that you are probably aware of is sodium hydroxide, which is NaOH. Put into solution, that dissociates and produces Na+ and OH-. And the more OH- that are present, the more alkaline something is. And again, we're on that kind of scale dependent on how much what we say is that it dissociates, how much of it breaks down, how many of those OH- ions are we producing. Now alkalis tend to be quite soapy, and again I am not suggesting that you go around feeling different substances. You know, if you're going to have a feel of bleach, make sure you've got some gloves on. However, if you look at it, you can see like washing up liquid, any forms of soaps, toothpastes tend to be quite alkaline. Cleaning products, soapy products are where you're going to find your alkalis at. Okay. Now, when we react an acid with an alkali, if you think about that scale, they kind of come and join in the middle at that neutral point. And so when we have an acid and an alkali, we get a salt plus water produced. So what we're going to look at is what is it in terms of the ions that are what's going on to produce that neutral solution. And then in the second part of this session, we're going to look at how we name those salts. So there are a couple of different types of reactions that we're going to look at, but if we focus first of all on an acid and an alkali. So underneath I've put this symbol equation, because I said to you earlier that acids produce H+ ions. Your alkali produces OH- ions, and what that does is if we look at this formula, if we bring these closer together, we've got H+, OH-, they're going to be attracted together because they're oppositely charged ions. And if we were to write their formula, we've got hydrogen once twice, so we're going to put H little 2, and we've got 1 oxygen. And so therefore we can see that that actually produces water. And some questions will ask you to explain in terms of ions and molecules what is happening when an acid reacts from an alkali. So we would say that the H plus ions from the acid react with the OH minus ions from the alkali to form a molecule of neutral water. Okay, so that's why we get this neutralization. Now you can see that's not the full story because we've got a salt in there. We haven't yet talked about the salt. This is simply how those ions come together and produce the water. And now what we're going to have a look at is how do we name those salts, what type of salts are produced, and the different types of reactions that occur to produce different salts. Okay. So when an acid reacts with a metal oxide or an hydroxide, so these are both capable of neutralizing an acid. And if we look at that reaction, hopefully straight away you start thinking, well, okay, yes, because we're producing that water, and we've just explained how that is a neutralization reaction. So what we need to think about is where is the salt coming from? What salt's going to be produced? Now the salt that is produced depends on two things. It depends on the metal of the oxide or the hydroxide that you've used, and it depends on the type of acid that you have used. Okay, so we'll look at them and we'll summarise the 3 main types of acid that you will come across and the names of the salts that they produce. So let's keep it nice and basic to start with. Let's stick with what we're going to look at in the next session in producing a soluble salt. So a very common example, we're going to take hydrochloric acid and react that with copper oxide. So you can see we've got an acid plus a metal oxide, and the way that we name these, so I've given you this nice little colour-coded diagram to help. When we name the salts, remember this is the salt that we're producing. We're producing copper chloride. So what we do is we take the name of the metal first, and then the ending name of the salt comes from the acid that we have used. And because we've used hydrochloric acid, that produces a chloride. And what we'll do is we'll summarise them on the next slide where I've got some more examples for you. Just wanted to work through this one with you to show you where these are coming from. So if we do this in terms of symbols, HCl plus our copper oxide, which is CuO. Okay, now remember we're always going to have those H plus ions react with those OH minus ions and produce the H2O. So what I want you to think about now is essentially, so this isn't at the moment isn't balanced, but essentially those hydrogens, because remember they split into H plus and Cl minus, this is going to split into Cu plus and O minus. And again, I haven't balanced anything, we're starting very basic just to show you where these are coming from. So those hydrogens and those oxygens are going to form that water. So what we've got left over is the Cl and the Cu plus. So these come together to form copper chloride. Okay. Now I haven't done any balancing, I haven't got the charges on the ions correct. This is to simply try and show you, help you to start and understand where those have come from. Okay, it's a little bit more complicated than just this. Okay, but hopefully you are aware that metals lose electrons and therefore become positively charged, and if we just kind of keep that in the back of our minds, we can kind of see where all these things are coming from. Okay, so let me show you some of the other examples and we'll just produce a small summary of what acid is used and therefore what salt we get formed. Okay, so I'm just going to highlight over some of these because, as you can see, they're all colour coordinated. I don't know what colour to go for. If I can just sort of highlight it in a grey and then I'm not interrupting the colours. Okay, so hydrochloric acid plus sodium hydroxide. So again, we've got the hydrochloric producing the chloride. Here we've got sulfuric acid with zinc oxide. So it's the sulfuric bit that goes on and produces a sulfate. And then we've got an example of nitric acid. So when nitric acid goes on and that produces a nitrate. You can see in all of these examples the name of the metal comes first, and then it's the ending of the salt that we're producing comes from the name of the acid that we have used. So a hydrochloric acid will always produce something chloride, sulfuric is the metal sulfate, and nitric is the metal nitrate. Okay. Now we could go on forever unpicking all these formula and looking at the charges of ions and how we produce ionic compounds and lots of other things. That's for another session. In this today, if you are happy and you can say, right, we use hydrochloric acid, we produce something chloride, then that is what I want to achieve today. Okay. So the final one, so remember that was with metal oxides and hydroxides, and the final variation that you might see is a metal carbonate with an acid. So very similar in terms of what happens. We still get a neutralization reaction. You can see we're still producing water. We still get the salt produced in the same way, so we take the name of the metal first, the ending from the acid that we've used. The slight difference here, because we are using a carbonate, we get carbon dioxide produced as well. And one of the big clues, and often questions will give you something very similar, so they might give you the same metal oxide, and it might ask you what difference would you see between a metal oxide and a metal carbonate. Well, because we are producing carbon dioxide, because we've got that metal carbonate, we're going to see that fizzing. So in the little diagram above, you're going to get that fizzing because carbon dioxide is being produced. It's a gas, we're going to see fizzing, bubbling, however you term it. Okay, so exactly the same process. If we just look at, we've got sort of one of each example again. We've got sulfuric acid, hydrochloric and nitric. Exactly the same idea going on. Take the name of the metal first. We've used sulfuric, so we produce sulfate, and then we just need to remember that because it was a carbonate, we get carbon dioxide present as well as our water. Okay, so there you've got a few different examples again, just to give you that overview, an example of each. Okay. So let's have a look at some questions and sort of bring everything together. Now it's entirely up to you whether you wish to pause the video at each new slide and have a go at the questions and check back in, or you can simply work along with me. So this question is a sort of lower demand question because we have a multiple choice, so we've got a tick box. As I've said previously, just always check what does it say, tick one box, therefore we just do need to tick one box. If we get ourselves a little bit overexcited and we go, right, okay, which ions do acid produce? Yes, H minus. Oh, no, it's not, it's H plus. I can delete it on my screen. In your exam, let's face it, you've got your black pen at the ready and away you go. If you decide to change your mind, make sure it's really obvious that you no longer want that one and you tick your correct box. Because if you do get yourself in a little bit of a panic and you end up leaving it that way with two tick boxes, you won't gain the mark. Even though you have correctly ticked to the right box, we could just go through and tick all four. Well, one of them's going to be right. So we have to just make sure that we're really getting rid of that one. Obviously, power of technology, I can just delete my line. Okay, so acids produce H plus ions. Part B, we've got calcium hydroxide reacts with an acid to form calcium chloride. So what we want to be doing here is looking and saying, well, we're getting chloride produced, therefore we need hydrochloric acid. Okay, and as always, we've got a neutralisation reaction. We've got a hydroxide with an acid, therefore our second product is going to be water. Okay, sticking with the kind of lower demand questions, you've still got to have this knowledge, you've still got to know which acid produces what type of salt, but we've got a little bit of guidance because we've got those multiple choice ones. Okay, so it tells us that zinc nitrate is a salt, and a student produces zinc nitrate using an acid and a base. Which acid should the student use to produce a zinc nitrate? Remembering it's the second part of the name of the salt that gives us a clue to the acid, therefore we must need to have used nitric acid. Which base should the student use? So the base is what gives you the naming of the metal. So here we're looking for something that's what's going to give us the zinc. Well, bases are oxides. And if we look at it, if we think, well, chloride, that would come from hydrochloric acid. That's not a base, that's the acid that we're using. Zinc sulfate, yeah, again, that is the salt that we're producing because that would come from sulfuric acid. And we're looking for the base. We're looking at what do we react together, not what do we produce. Okay, part C, sodium oxide is added to water and shaken. The pH of the solution is 14. What would the colour of the universal indicator? That would be purple. That's on the very far end of the scale, so that would be right into the purples. And aluminium oxide reacts with hydrochloric acid to produce a salt. What is the name of the salt? So we've got the name of the metal, aluminium, and the chloric bit is going to produce chloride, so we're going to have aluminium chloride. Okay, taking it up a step then. So this is kind of in the middle because we are finishing the word equations. We've got some options in a box and we have to choose the correct substance from the box. My best hint and tip, choose a substance from the box. Don't make up your own. Choose one from the box. Okay, so we've got ammonia plus something gives us ammonium nitrate and water. Here's our clue, is that it produced nitrate. Let's have a look in the box. Yes, we've got nitric acid. So nitric acid is what we're going to use to finish that word equation. Something plus hydrochloric acid. So we want something that's got potassium in it. This is our acid, so we're going to either need a hydroxide or an oxide. So the two that have got potassium in them is potassium nitrate. That is a salt because it's got nitrate on the end, so therefore we're going to have potassium hydroxide. Okay, so hydroxide plus acid, salt and water. 1 mark for each correct selection. Okay, sodium carbonate reacts with acids. Complete the word equation. Sodium carbonate plus hydrochloric acid, sodium chloride, something and water. This is checking, this is testing. Have we noticed that it is a carbonate? So because it is a carbonate, we're also going to produce carbon dioxide. Still get our salt and water produced, but that carbonate reacts and produces carbon dioxide gas. Name the salt produced if sodium carbonate reacts with dilute nitric acid. So we're going to take the name of the metal first, so we're going to have sodium, and remember that nitric acid becomes nitrate. Okay. And here then we've got a little bit of this is a sort of mid to high level question, because this is a bit more of a written answer, and it's an explain. Explain in terms of ions and molecules. Got to understand what ions are. Ions are charged particles. Molecules is going to be more than one thing bonded together. Compounds could be molecules. Hydrogen in H2 bonded to itself would be classed as a molecule. It's basically where we've got more than one atom attached, but it might not be a compound, it could still be an element. So what happens when any acid reacts with any alkali? Okay, so acid, we need to be thinking that this is H+. An alkali produces those OH-. The molecule we're going to get produced is H2O. Okay, so basically the 3 marks, we want to say that the H+ from the acid reacts with the OH- from the alkali and produces molecules of water or molecules of H2O. So we're going to say H+ ions, and I'm going to be specific and say ions because it says that in the question. H+ ions from an acid react with OH- ions from an alkali form molecules of H2O. And that's our neutralisation part. Okay, and then on to the final one. So this is a higher level question, because here it's asking us about what type of reaction, write a balanced symbol equation, and then, as I said to you earlier, the difference between two similar reactions. So this is really testing the sort of finer details, if you like. So we've got calcium chloride is a soluble salt. Calcium chloride can be made by reacting dilute hydrochloric acid with either calcium oxide or calcium carbonate. As long as we are getting that metal to produce the calcium chloride, then either would produce it. Name the type of reaction that takes place when dilute hydrochloric acid reacts with calcium oxide. It is going to be a neutralisation. Both of them, in fact, would be a neutralisation reaction because we're producing that salt and water. Write the balanced symbol equation. Okay, so I'm almost going to start backwards, and I'm going to start with my CaCl2 plus the water. So what do I need? I'm using calcium oxide, which is CuO, plus hydrochloric acid, which is HCl. Now we can see here we're given the formula of the calcium chloride up there, so I've taken it down here. We've got 2 chlorines, therefore we're going to need a big 2 in front of the HCl to get 2 chlorines. That will give us 2 hydrogens, which are there in the H2O, so that's fine. 1 copper. Why did I start with copper oxide? That should be calcium oxide, my apologies. Quick fix. We've got 1 calcium and 1 oxygen, and therefore it is balanced. You get 1 mark for correctly putting in the symbols of the CaO, HCl and H2O, and then 1 mark for correctly balancing with that big 2 in front of the HCl. And then the final question, this is: a student added solid calcium oxide to dilute hydrochloric acid. Then they added solid calcium carbonate in another beaker. The difference you would see between the reactions. Here we've got calcium oxide, but in this one we've got calcium carbonate. They're both going to produce a neutralisation reaction. However, because we have carbonate present in the second one, we're going to see fizzing. So we can say that there will be fizzing or bubbling with the calcium carbonate. Because remember, with our calcium oxide, we're simply going to produce the salt and water, no gas being produced, therefore we're not going to see that fizzing. Okay then guys, I hope you found that session useful, and as always, if you've got any questions, please do reach out to me. Otherwise, I'll see you next time.